Hello students, in this chapter we are going to see about real numbers. What do you mean by a real number? Do you have any idea about the number system what we have? Let me explain that. This is the diagram which we are using for representing a number system. In that, the very first set what we have is the set of all natural numbers. Natural numbers are nothing but it starts with 1, 2, 3, 4 up to infinity. So when we include 0 with this natural number, that set is called the whole numbers. So whole numbers are from 0, 1, 2, 3 up to infinity. In the left side, if we include the negative values, that is minus infinity to minus 2, minus 1, 0, 1, 2, 3, etc. No, that set is called the set of all integers, and the symbol for integers what we have is Z. Then come to the rational numbers. Rational numbers are of the form P by Q, where the denominator Q is not equal to 0. You know why we are restricting this Q not equal to 0? Can you tell me what is a number by 0? P by 0. It is infinity. Infinity means it is a very large number. It is not defined, right? So that's why we are restricting P by Q where the denominator is not equal to 0. That is the set of all rational numbers set. And set irrational numbers. Irrational numbers. Irrational numbers are of the form root 2 pi. Pi means 22 by 7 or 3.14. Root 3, root 72, root of 8 by 23, then exponent e. All these elements are set of all irrational numbers. Can you tell me whether this root 4 is a irrational number? It is a irrational number or not? No, it is a, because root 4 is equal to 2. What number it is? It is a, actually from here when you start, no, it is the natural number. It is a natural number. So it is not a rational number. Sorry, it is not a irrational number. It is a rational number. Okay. So the number which is not a perfect square within the square root we have, no, that is irrational number. So root 2 is irrational, but root 4 is not irrational because 4 can be written as 2 squared. It is a perfect square, so we can take it outside the root. So such a number is a rational number. Is it clear? So when we include the set of all rational numbers and irrational numbers together in a set, that set is called the set of all real numbers. So it includes everything. These values and these values together in a set. No, that is the set of all real numbers. Is it clear? Now come to the fundamental theorem of arithmetic. Every composite number can be expressed, that is, can be factorized as a product of primes, and this factorization is unique because we can do it in a unique way apart from the order in which the prime factors occur. Every composite, I repeat, every composite number can be expressed, that is factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Can you tell me what is a prime number and a composite number? What is a prime number? Can you give me example for prime number? Is 2 a prime number? Yes, 2 is the first even prime number. From here only the prime number starts. 2 is the first even prime number. So prime number means it will have only 2 factors, 1 and itself. So a prime number will have only 2 factors, 1 and itself. That means that a prime number can be divisible by either by 1 or itself. For example, when we take 2, so 2 is divisible by 1 and 2 is divisible by itself. So only these 2 are the factors for 2. Other than prime numbers, whichever number we have in the number system, no, that is composite number. 1 is neither a prime number nor a composite number. Neither a prime number nor a composite number. So 1 does not belongs to these 2. From 2 only we are starting the prime number set. Is 3 a prime number? Yeah, because 3 has only two factors, 1 and 3. Is 4 a prime number? No, it is a composite number because it has factors 1, 2 and 4. Apart from 1 and 4, it has a different factor 2. So it is not a prime number, it is a composite number. So from here only the composite number starts. Is it clear about prime number and composite numbers? Do you know what is a even number and odd number? Even number starts with 0, 2, 4, 6, 8, etc. Odd numbers are 1, 3, 5, 7, etc. So general representation of an even number is 2n, and for an odd number it is 2n plus 1. These two are the general representations. Either for this n, no, we can use 2p plus 1 or 2q plus 1, anything, okay. But generally we can represent a even number by 2n and odd number by 2n plus 1. The first problem what we have is we are going to express 3825 as a product of its prime factors. So we are going to find the factors, that is prime factors of this number 3825. How to do it? Using division algorithm only we are going to do. So 3825. Since it ends with 5, we can take 5 as a factor. So we are going to divide this number by 5. So 7s are 35, remainder 3, 32, 6 are 30, remainder 2, so 5 5s are 25. So 35, remainder here 3, 32, 60, 6, so remainder 2, 25. Now since it is ending with 5, I can take 5 as a factor. So 1 time it is 5, remainder 2, 25, 5 times, remainder 1, 3 times, 1, 5, 3. So what is the number next I can take? 3. 3 5s are 15, then 3 1s are 3. Here also I can take 3. So 3 1s are 3, 17. After that, is it possible to take any number dividing 17? No. See, whatever factors we are taking here, no, those numbers we have to take only prime numbers. So 5 is a prime number, 3 is a prime number, and 17 is a prime number. So the given number can be written as 5 into 5 into 3 into 3 into 5. Sorry, it is not 5. The last one is 17. Right? 5 into 5 into 3 into 3 into 17. 5 into 5, 5 squared. So totally we have 2 terms in 5, no? So 5 to the power 2. Then 3 2 times. So 3 to the power 2 and 17. So this is what we got. So we have represented the number, given number 3825 as a product of its prime factors. Is it clear? Now come to the LCM and HCF. Here two numbers are given. We are going to find the LCM and HCF by prime factorization method. So first we have to split the given numbers into its prime factors. Then we have to find LCM and HCF. So what is the LCM? LCM means the least common multiple. The least common multiple. And what is HCF? Highest common factor. Highest common factor. So first we have to split this into prime factors. So 6 can be written as 3 into 2. So 3 is a prime number and 2 is a prime number. 20 can be written as 2 into 10. 10 can be written as 5 into 2. So 2 is a prime number, 5 is a prime number, as well as 2 is a prime number. So we have splitted. For HCF, first we will write what is HCF. HCF means we have to take only the common factors. So whichever is common in both the numbers, we have to take that as HCF. So 2, 1, 2 here, the other one 2. That is common. Anything else is common? 3 only we have in 6. and 5 only we have in this 20 and as well as this 2. So only 2 is common in both the terms. Therefore, HCF of 6, 20 is 2. Now come to the LCM. What do you mean by LCM? That is the least common multiple. So whichever number is common, we have to take that once. So 2 is common means 2 will come one time. And whatever terms we have, the balance, no, we have to write in the terms. So here, after taking this 2 common 2, we have balance factor 3. So we have to take that from 6. And from 20, 5 is balance and 2 is balance. So 5 into 2. So HCF means whichever factor is common, only that factor we have to take. LCM means whichever factor is common, that has to be taken. After that, all the remaining factors we have to take it down. So 2 into 3 into 5 into 2, which is equal to 5 2s are 10, 10 3s are 30, 30 into 2, 60. Therefore, LCM of 6, 20 is equal to 60. So HCF is equal to 2 and LCM is equal to 60. We have one property here connecting LCM and HCF. See the HCF and LCM. When we multiply these two, what we are getting? 120. What is the number when we multiply HCF and LCM? 120. When you multiply these two numbers also, 120. So the property what we have is product of LCM and HCF is equal to product of the numbers. So I repeat, what is the property we have? Product of HCF and LCM is equal to, for example, the numbers be A and B. Product of HCF of A and B and LCM of A and B is equal to the product of the numbers. So A into B is equal to HCF of AB into LCM of AB. So if one term is given, means easily we can find the other using this property. So make a note of this property. Using this we can do problems. Okay. This is the next problem what we have. We are going to find the HCF of 96 and 404 by the prime factorization method. Hence find their LCM. So what is given? The two numbers are given as 96 and 404. First we have to find the HCF. After getting the HCF, we are going to find what is the LCM. Okay, so for that we are going to use the division algorithm for finding the prime factors of 96. 96 can be divided by 2 as well as 3. First I am going to start with 3. 3 3s are 9, 3 2s are 6. Now we are going to use 2. 2 means 1, 16. Then 2, 8. Then 2, 4. Then 2, 2. So this is the last factor we are getting. So 3 into 1, 2, 3, 4, 5. 5 2s. So 2 power 5 into 3. So 96 is equal to 2 power 5 into 3. Now come to 404. We can start with 2. So 202. Then we can start with 2. 101. Do you have any factor for 101? No, it is a prime number. Therefore, 404 can be written as 2 to the power 2 into 101. What is the first thing we have to calculate? HCF of 96, 404, which is equal to, we have to take only the common factors. 2 power 2, 2 power 5. What is common in both the terms? 2 power 2. The least power is common. Don't take the highest power. Only we have to take the least power of 2. So 2 power 2, which is 4. So we got the HCF as 4. So the given numbers are 96 and 404. And we got the HCF as 4. So we have answered for the first question. After finding this, we have to find the LCM. We can use the property. Directly we can find the LCM, but here we are going to use the property. What is the property we have? HCF into LCM is equal to product of the numbers A and B. Here A is equal to 96 and B is equal to 404. HCF we got as 4. So 4 into LCM of 96 and 404 is equal to 96 into 404. Therefore, LCM is equal to 96 into 404 by 4. So when we divide, it is 101. 101 into 96, which is equal to 9696. Therefore, LCM of 96404 is equal to 9696. Without using the property, we can find the LCM. Okay. So tell me, what is the LCM from here? For LCM, we have to take the highest power. So 2 power 5, 2 power 2. Which is highest? 2 power 5 is highest. Then after that, whatever balance we have now, 3 and 101 has to be multiplied. So 2 power 5 into 3, actually we know it is 96. 96 into 101, that only we got as 9696. So either in this way directly we can find, or using the property we can get the answer. Is it clear? The next problem is, we are going to find the HCF and LCM of three numbers 6, 72 and 120 using prime factorization method. So we have, instead of two numbers, here we have three numbers. 6, when we divide it by 2, it is 3. 72 can be either divided by 3 or 2. So when I start with 2, it is 36. Then 2, 18. Then 2, 9. Then 3, 3. 72. These are the prime factors. 120, we can start with 2, 60, then 2, 30, then 2, 15, then 3, 5. So 6 is equal to 2 into 3. 72 is equal to 2 into 2 into 2, that is 2 power 3, into 3 into 3, that is 3 power 2. Then 120 is equal to 2 into 2 into 2, that is 2 power 3, into 3 into 5. So therefore HCF of three numbers 6, 72 and 120 is equal to, which is common in all the terms, this 2, 2, 2. 1, 2 is common. Then 1, 3, 3, 3. So 3, which is equal to 6. 6 is the HCF. LCM is of 6, 72, then 120 is equal to 1, 2 is common, 1, 3 is common. After that, we have to see the terms. I have rewritten like this. This is 2 into 3. 72 is 2 to the power 3 and 3 to the power 2. 120 is 2 to the power 3, 3 power 1, 3 power 5. We have to take the highest powers, right? So 2 power, which is the highest power? 2 power 3. So we have to take LCM as 2 power 3 into 3. What is the highest power for 3? 3 power 2. 3 power 2 into 5, we have only 1. So we have three factors, 2, 3, 5. We have to take the highest powers for all the factors. So from these numbers, 2 power 3 is highest, because in the first one we have 2 power 1. So we have to go with the highest power. So 2 power 3 is highest. Then 3 power 1 we have, 3 power 2 we have here, 3 power 1. So 3 power 2 is the highest, and 5 only 1 power we have, 5 power 1. So which is equal to 360. So the LCM what we are getting is 360, and the HCF what we got is 6. For three numbers, we saw one property for two numbers, no. LCM into HCF is equal to product of A and B. For three numbers A, B, C, that is not applicable. HCF of A, B, C into LCM of A, B, C is not equal to the product A into B into C. So this is not applicable for three numbers. For example, in this problem itself, no, when we multiply these two, what we are getting? 6 into 360. So 6 into 360, which is equal to 2160. When we multiply the three numbers, the numbers given are 6, then 72 and 120. We are getting a 5-digit number 51840. So this property is not applicable for three numbers. The next problem we have is consider the number 4 power n where n is a natural number. Check whether there is any value for n for 4 power n ends with the digit 0. So what is a number? For example, if I take a number 10, it ends with 0 means 10 is divisible by 5. When I take 20, it is divisible by 5. 100, it is divisible by 5. So in general, we can say a number ends with 0 means it will have the factor 5. Am I right? So what we are going to do is we are going to factorize this 4 power n. 4 power n can be written as 2 into 2 power n. 2 into 2 means 2 power 2 the whole power n. So which is equal to powers we can multiply. So 2 power 2n. So 4 power n is equal to 2 power 2n. So what we have one theorem, in a unique way we can represent a number in its prime factors. So 4 is having only 2 as its prime factor and the power for 2 is 2 power n. This is not divisible by 5. 2 is not divisible by 5. Therefore 5 is not a factor for 4 power n. Therefore, so we don't have any number ends with 0. Is it clear what I said? So what they are asking is they have given a general term 4 power n. For n takes values maybe 1, 2, 3 because they start saying n is a natural number. No. So 4 power 1. 4 power n is 4. 4 power 2. 4 power 2 means 16. 4 power 3. 4 power 3 means 16 into 4. 64. Then 4 power 4. 4 power 4 means it also ends with 6. Then 4 power 5 means it also ends with 4. So see, repeatedly when we take the powers, it ends with either 4 or 6. 4 or 6. Like that only we are getting. We are not getting a number which is which ends with 0. That is only they are asking for which value of n this power ends with 0. For that, we are not able to say in this way. For that, what we are going to see is we have to first factorize this 4. So 4 power n can be factorized as 2 into 2 power n, which can be rewritten as 2 power 2 the whole power n, which is 2 power 2n. So 2 power 2n means 2 is the prime factor. 2 does not divided by 5. So we are not able to divide 2 by 5. Therefore, we don't have any number ends with 0. Is it clear? For the same problem, if they are asking, find the which value for n, this 6 power n ends with 0. The same procedure, if a number ends with 0 means it has to be divided by 5. So first we have to factorize this 6. 6 power n is equal to 3 into 2 the whole power n. So 3 is not divisible by 5 and 2 is also not divisible by 5. 2 is also not divisible by 5. Okay. Therefore, there is no natural number for 6 power n which is divisible by 0. Is it clear? Now come to the irrational numbers. What do you mean by an irrational number? Root 2, root 3, root 5, are they irrational numbers? Irrational numbers. Already in the number system itself, I have explained within the square root, if we have a perfect square, it is the rational number. For example, if we have square root of 4, it is 2. So it is the rational number. So these numbers are irrational numbers. Am I right? So root of p is an irrational number where p is a prime number. 2, 3, 5 are prime numbers? No. So these numbers are irrational numbers. So S is a rational number if it cannot be written in the form P by Q where Q is not equal to 0, because for representing a rational number we have the format P by Q where Q is not equal to 0. So any number of this kind is called rational number. Other than that we have this format, no, that is irrational number. Is it clear? This is a theorem we have. If P is a prime number, let P be a prime number. If P divides A squared means then P divides A. So let P be a prime number. If P divides A squared, then P divides A where A is a positive integer. Let P be a prime number. If P divides A squared, then P divides A. For example, P is a prime number, so I am taking P as 2. This 2 divides 4. Am I right? This symbol denotes divides. 2 divides 4 means this 4 can be divided by 2 without any remainder. That is, when we divide 4 by 2, 2 2s are 4. The remainder what we get is 0. So we can read this as 2 divides 4. That is, 4 can be written as 2 squared. 2 divides 2 squared. We also know that 2 divides 2 because when we divide 2 by 2, we take 1. So 1 2s are 2, then 0. So 2 divides 4, that is actually 2 divides 2 square, which implies 2 divides 2. Is it clear? For example, one more example I am taking, 3 divides 9. That is 3 divides 3 square, which implies 3 divides 3. So we have a theorem, if P is a prime number, that prime number divides a square means, A squared means that divides A2. Is it clear? The next problem what we have is, we are going to prove root 2 is irrational. At the beginning itself, when I talk about the number system, I told a number of the form root P where P is a prime number. P is a prime number is irrational. 2 is a prime number, so root 2, root 3, root 5, all the numbers are irrationals, but we have to prove it. Okay, so we need a proof for this. Such kind of questions are very important. You may get a question of this format. They will ask you to prove root 2 or root 5 or root 3, any number as an irrational number. Okay, so we are going to prove. What is to prove? To prove is root 2 is irrational. Okay, suppose not. Suppose not means what we have to prove? No, we are taking opposite to it. We have to prove root 2 is irrational. So we are taking opposite to it, that is root 2 is rational. This is called contradiction proof. Contradictory proof means what we have to prove originally, opposite to that, negative of it we have to take. So we are taking root 2 as a rational number. Already we know that any rational number is of the form P by Q where Q is not equal to 0. Am I right? So root 2 can be written as P by Q where P and Q are integers with the condition Q is not equal to 0. Am I right? So P may have a common factor other than 1. For example, if I take the fraction of the form 4 by 8, both are having 4 as a common factor. After cancellation, we are getting 1 by 2. Right? 1 by 2. What is the common factor 1 by 2 having? 1 comma 2 having? It is 1. Such numbers are called coprime numbers. What do you mean by coprime? Coprime of A and B. We can say A and B are coprime when the greatest common divisor of A and B is 1. When we write in this bracket, no, we have to read this as GCD of A and B. Within brackets AB equal to 1 means in words we can say GCD of A and B is 1. Greatest common divisor of A and B is 1. Other than 1, they don't have any common factor. Such numbers are called coprime numbers. So which implies, therefore we can write root 2 is equal to a by b, where a and b are co-prime. So co-prime means both are having 1 as the common divisor, GCD. So on us multiplying b in this side, we are getting root 2 into b equal to a. Squaring both sides, this will become 2, b squared is equal to a squared. Am I right? Therefore, a squared is equal to 2b squared. Which implies from this result, no, a squared is a product of 2 and b squared. So this is one factor and this is one factor of a squared. That means 2 divides a squared. This symbol denotes 2 divides a squared. A squared is great. For example, I can say 2 divides 8. 8 is greater and 2 will divide 8. So when we divide by 2, 8 by 2, we are getting the remainder 0. In that case, when we get the remainder 0, we can say 2 divides 8. Like that, a squared is a product of 2 and b squared. So 2 is one factor and b squared is one factor. So we can say 2 divides a squared as well as 2 b squared divides a squared. We are taking this one. So 2 divides a squared. We have one theorem, no. What theorem we saw? When p divides a squared, p divides a also. We saw one theorem, no? So we are going to use that. In the place of p, we are having 2. So this 2 also divides a. So this is the result now we are getting. So from this we are getting 2 divides a. 2 divides a means a can be written as a multiple of 2. So 2 into something. That multiple we are taking as c, but c is an integer. So a is equal to 2 into c. Now squaring both sides. So a squared is equal to 4c squared. Already we have 2b squared is equal to a squared. No, this we are going to use now. So what we have, 2b squared is equal to a squared, which is equal to 4c squared. Am I right? So combining these two together, we are getting, which implies 2b squared is equal to 4c squared. Cancelling 2 on both sides, we are getting b squared is equal to 2c squared. Now b squared is a product of 2 and c squared. So this is one factor and this is one factor. Therefore 2 divides b squared. Using the same theorem, p divides a squared means p also divides a, where p is a prime number. So which implies 2 is a prime number. So it divides b squared means that also divides b. Okay. Previously we got 2 divides a. Now we got 2 divides b. So 2 is a common factor for 2 is a common divisor or factor, divisor of a and b. But beginning what we started with, a and b are co-prime. What we took, a and b are co-prime. That means a and b are having the common factor or common divisor 1. But here we are getting that as 2, which is a contradiction. This symbol is for contradiction. What we have started and we are getting, no, that is not true, because how we started, a and b are co-prime. So this is a contradiction. Therefore, how we started, no, root 2 is rational. That is not possible. Therefore, root 2 is an irrational number. This is the way how we are proving a result. Actually, positively we can start and we can prove. But here, one more proof we have, contradictory proof. That is what we have to prove. Now, opposite to it, we have to start and we have to finally get a contradiction. That means how we started, this one is not true. Therefore, root 2 is rational, is not possible. It is not possible. Therefore, root 2 is rational. That hence we proved the result. This is very important. Root 2 we proved, no, like that they may ask you to prove root 3 or root 5. So in the place of 2 you have to start with 3. In the place of 2 you have to start with 5. Is it clear? The next problem is we are going to show 5 root 3 is a irrational. So what we are going to prove, 5 minus root 3 is irrational. we are going to start with the contradiction. So let 5 minus root 3 is rational. Rational number means 5 minus root 3 can be written as a and b, where a and b are integers, a and b are integers with b not equal to 0. So from this you take 3 to this side, a by b to this side. So which implies root 3 when it goes this side it will become positive, which is equal to a by b when it come to the other side it will become negative. So 5 minus a by b. 5 minus a by b, when you take the LCM it is 5b minus a by b. A and b are integers, therefore 5b minus a is also an integer, b is also an integer. A by b, where b is not equal to, a by b means an integer by another integer, where the denominator b is not equal to 0 means it is a rational number. So from the result what we are getting is root 3 is rational, which is a contradiction because we know that root 3 is irrational. Therefore what we started here, no, 5 minus root 3 is rational, that is not possible. Therefore 5 minus root 3 is irrational. Is it clear? The next one is of same kind but the format is different. 3 into root 2 is irrational. Okay, same procedure. We have to start with 3 root 2 is rational. I'm sorry, not irrational. It is a rational number. So rational number, any rational number can be written as a by b, where a and b are integers with b not equal to 0. Bring this 3 to the other side. So root 2, it is root 2. Root 2 is equal to a by 3 into b. So this is an integer and this is also an integer. B is an integer, so when it multiply with 3, it is also an integer with the denominator not equal to 3b not equal to 0. Therefore it is a rational number. So therefore root 2 is rational, which is a contradiction because we know that root 2 is irrational. Therefore what we started here, no, that is not possible. Therefore 3 root 2 is also irrational. Is it clear? These are the properties what we saw. HCF of A and B and LCM of A and B. When we take the product, it is equal to product of the two numbers. Using that property, if one is known, the other one is not known means we can easily find. HCF is known means LCM we can find. LCM is known means HCF we can find. This is for two numbers, but this is not the case for three numbers. When we take three numbers, HCF into LCM is not equal to the product of the three numbers. But we have a property, LCM of PQR is equal to P into Q into R into HCF of PQR by HCF of 2 PQ, HCF of QR, HCF of PR. We have to take the sum. Okay. HCF of PQR is equal to P into Q into R into LCM of PQR by LCM of PQ plus LCM of QR plus LCM of PR. These two properties we have, but this is not possible. The next problem is we are going to find the greatest number which divides 85 and 72, leaving remainders 1 and 2 respectively. So what they have given, if you divide 85, we are getting the remainder 1. When we subtract that remainder, that number will be exactly divided. So 85 minus 1 is 84. This 84 when we divide by the greatest number, exactly we can divide without any remainder. Similarly, 72 is having 2 remainder, so it is 70. 70 can be exactly divided by the greatest number. Any number, greatest number which divides these two numbers is HCF. HCF is the only number which divides both, and that is the greatest common divisor. Okay. So we are going to find HCF of 84 and 70. Directly they didn't ask you to find this. So the question is little bit twisted. What they are asking is the greatest number which divides. That means we are going to find HCF of these are not the numbers, right? They have given this number. When it is divided by this number, it leaves the remainder 1. So this minus remainder will give the number which is exactly divided by this one, leaving the remainder 0. Okay. So we are going to find the HCF of 84 and 70. So find the prime factors. So when it divided by 2, it is 42. Divided by 2, it is 21. Divided by 3, it is 7. So these are the prime factors. Therefore, 84 can be written as 2 into 2 into 3 into 7. And the other one is 70. Divided by 2 means it is 35. Divided by 5 means it is 7. So 70 can be written as 2 into 5 into 7. So this 2 and this 2 common. 7 common. Anything else we have? No. So only we have two factors. What are they? 2 and 7. So tell me the HCF of these two. HCF of 84 and 70 is equal to 2 into 7, which is 14. So the answer for this problem is 14. The next sum is, if P and Q are natural numbers and P is a multiple of Q, then what is the HCF of P and Q? So what is given? P and Q are natural numbers and P is a multiple of Q. For example, I have taken two natural numbers 2, 4. Okay, these two are natural numbers and this P and Q, no, not this is P. We can take in this way, 4, 2. Take P as 4 and Q as 2. These two are natural numbers and this P, that is 4, can be written as 2 into 2. 2 is Q, so 2Q. It is a multiple of Q. So P is a multiple of Q. So like that they have given. Now we are going to find what is the HCF. They are asking you to find HCF. HCF of 2 and 4 is 2. Am I right? Because 2 is 2 into 1. 4 is 2 into 2. So common factor what we have is 2. So HCF is 2. Like that, P and Q are integers and P is equal to multiple of Q. Multiple of Q means sum n into Q. Okay. Now we are going to find the next one is Q. So what is the common factor we have? Q. Therefore, HCF of P, Q is Q. Is it clear? So this is the answer. Is it clear? The next problem is the ratio of the HCF to LCM of the least composite number and the least prime number is. We have 4 options, no? So first we have to write the least composite number. Which is the least composite number? 4. Because the prime number starts from 2. 2 is the first even prime number. 1 is neither a prime number nor a composite number. This is a even prime number where it started, and 3 is the next prime number. 4 is a composite number. So 4 is the first composite number. Okay. So least composite number is 4 and the least prime number. What is the least prime number? 2 is the least prime number. For these two, we have to find what is HCF. Which is the HCF? 4 is equal to 2 into 2. 2 is equal to 2. So common term what we have is 2. LCM is of 4, 2 is equal to 2 into 2, 1, 2 we have to take into the balance 2. So 2 into 2, which is 4. Okay. So HCF is equal to 2. LCM is equal to 4. Okay. So what we have to find the ratio of the HCF to LCM. We have to find the ratio of HCF and LCM. So HCF is 2 and LCM is 4. 2 is to 4. In ratio, if we have a common factor, we can cancel it. Ratio 2:4 means 2 by 4. 2 we can cancel, so 1 by 2. So the reduced one what we are getting is 1:2. So this is the answer. Is it clear? The next problem is two numbers are in the ratio 2:3 and their LCM is 180. We are going to find what is the HCF of the numbers. So numbers are in the ratio 2:3 means we can let the numbers be 2x, 3x. Ratio means we have to take one constant. So 2x, 3x. Now we are going to find what is the LCM of 2x, 3x. So 2x is equal to 2 into x. 3x is equal to 3 into x. X is common. LCM means the common term, then the balance. So 2 into 3 will come. So totally it is 6x. That is the LCM here. So it is 6x. What is given? LCM is equal to 180. Therefore 6x is equal to 180. Am I right? Therefore what is x? X is equal to 180 by 6, which is 30. So x is equal to 30. Therefore the numbers are 2x and 3x. No, 2 into 30 60, 3 into 30 90. The numbers are 60 into 90. They are asking you to find the HCF. So 60, 90. 60 can be written as 3 into 2 into 5 into 2. Am I right? 10, 20, 60. Then this can be written as 3 into 3 into 5 into 2. What is the HCF we have? 3 is common, 5 is common and 2 is common. We have 3 factors as common. So finally the HCF is equal to 3 into 5 into 2, 5 into 2 10, 10 into 3 30. So HCF is 30. Is it clear? The next problem is that traffic lights are at 3 different road crossings change after the first light change after every 48 seconds, then 72 seconds and 108 seconds respectively. If they change simultaneously at 7 a.m. So 7 a.m. we are starting. One light will change at the 48th second. The second one 72 and the third one is 108. We are going to find at what time they change altogether at the next time. So at what time all will change together. Okay. So what are the numbers given? 48, 72 and 108. We are just going to find the LCM of these numbers. LCM of these numbers means we have to factorize and we have to take the factors, right? So when you find, you have to get the answer 432. Check whether you are getting this answer. So after 432 seconds, they will change together at the next time. 432 seconds means we are converting that to minutes. If you are converting seconds to minutes means we have to divide it by 60. So 432 by 60. So which is equal to 7 minutes and 12 seconds. This also you check. You have to get this answer. When you divide 432 by 60, you have to get the quotient as 7 and the remainder as 12. So 7 minutes 12 seconds. When you start at 7 a.m., 7 a.m., 7 minutes 12 seconds, all the three will change together next time. Is it clear? So the next problem is they have given two positive integers m and n, and m can be written in this format and n can be written in this format. We are going to find the HCF. So HCF means common terms p q power 3 and n is equal to p cube q square. Least powers only we have to take for HCF, right? So least power means the least power of p is p power 1 and the least power of q is q squared. So p into q squared. That is the answer. P into q squared. So P is q squared. Is it clear? So that's all this chapter. We have gone through real numbers and we proved the irrational numbers and we got LCM and HCF. You go through everything and I wish you all the best.